like to open it up to the audience. I'm sure you have many questions for the panel or for individual speakers. There's microphones over there. We can also pass.
All right. Thank you very much for this great panel discussion. I had a question with respect to the discussion about interventions and embodiment, right? There's a lot of differences between AIs and the way we interact with the world, but I would argue that especially large language models intervene on the human world, like at an unprecedented scale. Like we interact with these models.
Unwittingly, though.
Exactly, right? And so, but in some sense, maybe it's a question directed to Mr. Buzaki to begin with, because you said that that's a limitation between current AI and how humans work. But I would argue that in different modalities, it's actually quite here right now. And I was wondering if the modality in which we interact and compare things against one another, if it changes, do you think it makes a difference, or we would access different types of models of the world, such as LLMs?
Well, I started with a trivial comparison, a metaphor, that was the horse and the engine. You can make AI so much better than any brain function, perhaps individually. Do we need more? That's the question. Why do we need to replicate the human brain other than making AI better? But if you can make AI so much better in every single domain of human brain, then you don't have to worry about putting it together, because that's a tool. This is the externalization of brain function. So this brings us back to this real interesting question, is that should we solve the most exciting thing, but the most dangerous thing? I think your job is do it, because that's what scientists do. They discover things. Because if you don't do it, then the bad actors are smart too. They will do it. You probably have seen.
We've gotten in trouble that way before.
Okay, so I know it's a very interesting problem, because it took a long time to make an effective engine, but it doesn't take a long time to steal AI. So that's a consideration where I'm nobody. I don't even know where to start. All I know is that I'm a scientist. I'm obliged to discover things. And
I can tell you that national security agencies around the world are thinking heavily about these questions.
Well, Hollywood will figure out, and you have seen the movies.
Okay, we have a question over there.
Yeah, so during Yoshua's talk, I kept thinking when you were speaking about AI safety, about the climate crisis and the fact that there are many scientists many decades ago who were sounding alarm bells about a forthcoming crisis in a few decades that would affect everyone. And I just wonder if there's any social lessons that can be gleaned from that natural experiment that you could highlight or sort of unpack for us, and how you think we could do better with this potential issue that we might be facing. I know that you highlighted some of them toward the end of your talk, but I was wondering if you could unpack some of them, or if the two are related.
They are. We're talking about something could be catastrophic and that didn't happen. And it's difficult to convince people that they should worry about it. So climate scientists have made these models, and then they've tried that project into the future, which is something we can't do for AI, because we can't project how science is going to progress. So they were in a much better position. But we have the experience that they've had. So for example, for many years, they haven't really found a good way to communicate the danger. They use a very technical language. Only in recent years, people in climate activists have been making progress in understanding the psychological factors that make people pay more attention. If you just tell them, some scientific story, they don't pay attention. If you show them pictures of floods in India and they live in North America, they don't pay attention. If you show them pictures of floods in places they know, suddenly they start paying attention. So it's visual and it's something that relates to personally. So I'm just saying there are things we might be able to learn in terms of the communication strategy to make these very difficult, uncertain projections about the future that we need to act upon more accessible to more people, so that they can push our positions in the right direction to protect us all.
Great, thanks.
Okay, over here.
All right, so I had a question primarily to Joshua. At the beginning of your talk, you said you were concerned about having maybe AI emerge as some kind of like superior species taking over the world. And I mean, the kind of ChatGPT-like network, they're a species of like one, and they don't reproduce with each other because they're one. So I don't know if that would qualify for a species, but humans, we are many, we reproduce, we are, a couple billions, and I think diversity in humans is a great strength to actually find good solutions, because we don't see actually things exactly the same way. So do you think that diversity in artificial intelligence and the ability for artificial intelligence system to reproduce would be important to really push the frontier?
Okay, so diversity, of course, but in a way we already have some. Each lab working on these things explores a different solution. Now, it's not as many differences as between humans or different species and so on. If we, okay, so ChatGPT doesn't reproduce itself because we don't let it reproduce itself. If it was able to understand an objective of self-preservation, it would probably want, I mean, I don't think the current ChatGPT would, but let's say one that has a much better understanding of the world, maybe in 2 versions from now or 5 versions from now, I have no idea. If it had a good model of the world, it would understand that we could turn it off. And so what it would want to, if it had a self-preservation objective, is to copy itself on many other machines on the internet so that we couldn't easily turn it off. And that would be like, us reproducing ourselves. We can't copy ourselves, it's not physically possible, but these machines can. And so I think that this is a plausible scenario. If they understood that we could turn them off, and that they had this objective of not being turned off. Now they would still be missing the diversity, you're right, but once they also understand diversity, they might explore better ways of their improved selves and seek to not just copy themselves, but explore better versions of how do I understand the world, how do I control the world, how do I achieve my objectives, which is what AI is all about.
Thank you.
So I think the person over there was next, actually. Then.
Thank you. So following up on his question too, for the self-preservation, when it comes to AI, where does it go beyond just being a set of just computation and you give it an objective and it's just optimizing and computing for it? Is there a gap that can be bridged, or is it even possible for AI models or whatever it is to choose new objectives for themselves, or to actually be creative like a human? Like you go into the lab and you choose a question to explore, but AI, you would just give it a function that's minimizing the error rate to it. Is there a gap that actually can be bridged for such machines to do such a thing?
Okay, so there's already a lot of work in AI in reinforcement learning. So how do you train agents that have goals so that they, in order to achieve those goals that may be given to them, they will create other goals, sub-goals. So if you need to preserve yourself, as I said earlier, you might have a sub-goal to copy yourself so that you avoid being turned on. And you might have another sub-goal, which is to better understand the world. So you might want to experiment in the world. These sub-goals don't need to be programmed by us. They might just be something that emerges from the calculation, predicting what would happen if I do this and if I do that, and would that be a good thing with respect to my original goal.
Mm-hmm.
So sub-goals are things that are being studied. And if you look at how, for example, AlphaGo is playing the game of Go, it does that all the time. It is creative in finding solutions to problems. And in fact, AlphaGo found ways to play the game of Go that no human had found before.
So question on the left, next.
Hello. I am, maybe it's semantics, but I'm just trying to understand the intelligence that is without agency and with agency. So basically the discussion.
The pure scientists doesn't have agency, like the theoretical physicists, they don't do experiments.
Okay, so that's your definition. Because I was trying to wrap my mind, use ChatGPT as an example, and to me, the fact that the language model needs to be trained and it has outputs and it makes predictions, in a way, isn't that some sort of an effector? Because, I mean, especially with its text output, it acts on us and we give it feedback, and learning by itself to understand meaning has to be a correction. There has to be a correction for the error. So there has to be a prediction being made about something being learned. And isn't that an effector of sorts?
Yeah, there are basically two phases in training these dialogue systems. In the first phase, there are like pure scientists, not very good ones. They just observe texts and try to make sense of it. And then in the second phase, and then there is no interaction, there is no action, they just learn to predict. In the second phase, they interact with people and then they get feedback, as you said. And that's where they become agents.
So if I may reflect on this, because it relates to your statement that the machine can have a emergent property, which is a goal and a sub-goal. I don't intuit how
this is already done. Like people do it in machine learning. We could do it better.
Why would machines have goals? They don't have gains.
Sure. We can just train them. What do we call with goal condition policy? So they will act in response to stating a goal, which now we can use natural language for. So you could type, tell me how I can cook cheesecake, and that's the goal. And they will give you an answer, which is say a recipe.
Okay. So I have motivation to do that because various reasons. I may enjoy the result of it, or I may hate it. There are certain things that makes my agency reality. But what I'd like to understand is that what's in the equations.
In the case of ChatGPT, for example, its intrinsic motivation comes from two places. So one is that in this second phase of training, when it interacts with people and it gets feedback, it learns to behave in ways that people will give good feedback. So it's an implicit definition of a goal: please people. And it doesn't have enough data for that right now to be very good at it, but that's how we get from a language model which would not interact with us in a very nice way to what we get now. The other way that it has enough motivation is that there's what's called the pre-prompt. So before you ask your question, there's a whole set of instructions that OpenAI has put. And these instructions include things like, be polite and blah, 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 and answer the questions. And so they are goals, right? And they're fixed because they're hard-coded by the people who built this machine. So the machine, when it starts, it has goals, implicit goals due to getting good feedback, and explicit goals that were stated in English. Maybe it doesn't do what you asked, but at least that's been driving the behavior.
How is this goal different from a locomotive pulling a car?
Well, your brain is a locomotive.
Because it does the desire of the human agent, but it doesn't have its own goal. Well, and how is it different for AI than for a simple machine?
No, but evolution has put goals into you.
No, there are no goals in evolution.
Survival.
No. Paul can tell you that it's easy to explain everything, and this is what we do, and we come back to the words and the communication and everything from the point of view of a goal. But this is exactly the point of creationism, because there is a goal. because we can explain everything backwards, but
No, but that's the whole point of the theory of evolution.
goals. Nature doesn't have a goal. It looks like post hoc that there was a goal,
Well,
but
if
there
you-
was no goal from the beginning. This is the Henry
It's an implicit
Bergson
goal.
philosophy,
No,
and
but it's-
going back, that there is the vitalism. You know, there is a
No.
energy in the seed that
No, wait,
makes.
it's an
blah, blah, blah,
implicit
blah, blah.
goal. It's an implicit goal, right? So if you didn't have an implicit goal of survival and reproduction, and all these things that allowed our ancestors to survive the culling of evolution, we wouldn't be there. And so we have these implicit goals.
I'll just no.
I'll say thank
We'll
you,
go to
and,
another. I think we should go to another
yeah.
question, though. Over here, you were next.
Great, thanks. Thank you all for the talks. They were really enjoyable. I have a question mainly for Nancy, but the group in general can respond if you want to. I don't know why I'm giving you permission. Broadly, from a cognitive neuroscience perspective, I think of there being two broad, whether or not we're going to get into it, but goals for developing AI. One is to create a tool that can help us answer questions, and one is to replicate a human brain so that we can do things like lesion subsystems and learn about disease processes. Broadly, which do you think is more useful? I see that some of the stuff you're doing is kind of combining the two, which is exciting, but do you think that that we should be putting more emphasis on replicating biological systems and incorporating things like working memory constraints, or like layers of like visual cortex, for example, or just optimizing these tools to try to do something as best as they can and then seeing how that maps onto the brain?
I think it's really hard to tell what's going to pay off in science, and people are doing all these things and they should do all of them, and who the hell knows who's going to get some good stuff first. So it's good people have different intuitions about how to proceed. I personally, well, one, I don't have the engineering chops to go, developing new models and building in biological constraints. I would have no idea how to do that. My friends down the hall do, and bless them. Plus my interests are more, I just find it more exciting when you take systems that are just optimized to do some task and then compare them to brains. I'm not saying it's the only thing to do, it's just the thing I find most exciting at the moment.
Just add a short thing. The whole point of this conference is to bring together people, who are interested in the intersection between neuroscience and AI. And that's the point of Unique, the organization that's organizing this event. And yeah, it's a bet of whether we can do something that's going to be both teaching us about human brains or animal brains and helping AI. But up to now, it's paid off.
Thank you.
I think actually you were. Well, go ahead.
Hi, I have two questions for Joshua. And the first one is, have you ever thought about what would be the consequence if we build some sort of internet for the AIs? Because I realize that with collaboration, people achieve a lot more than they can individually. Maybe some sort of an internet where AIs can share their training weights or something, like it would lead on a faster way to AGI. And what sort of safety constraints would we have to put on such a system if we were to build it? And second question, I don't know.
My working memory contains only one question. Yeah, I'm not sure I fully understood all the words you said, but let me try. So was your question about having a separate internet for the AI?
Just the communication system for
No,
AI.
but that's we already doing. So people are training multiple learners together. It's called multi-agent reinforcement learning. In fact, GPT-4 seems to be built out of multiple networks that were somehow coordinated. And there's a lot of research in those directions where you do have multiple machines, each maybe looking at different aspects of the world or different parts of the data and communicating with each other, or cooperating to solve a problem and specializing in different aspects.
Thank you. And my second
So,
question.
no, actually, I think with respect to the other people. So we'd just like to have the three more people that stood up earlier. So you and you. and then we'll try to keep your questions short because I think everybody's getting a little hungry.
Thank you, Yuri, Nancy, and Joshua for the beautiful talks. I have a question directed at Joshua.
You need more diversity here.
So self-preservation, as you mentioned in your talk, is not a very good thing to build into AI for safety reasons and for survival reasons of the human race. But what do you think of the following hypothesis, that actually it's quite easy for it to emerge? For example, the scenario that I can think of is if you just have RL, but in a continual setting, then I think naturally the agent should not want to die, and in order to even just continue to get rewards. So what do you think of the hypothesis that it is not even something that is, we could restrict people from building per se, that it could just emerge in some very easy scenarios?
Yeah, there are a bunch of papers about this in the AI safety literature. One of the arguments I find the most convincing, and there's a lot of strong theory behind, it regards what's called reward hacking, which is very similar to the scenario you're talking about. And really, it's imagine that like ChatGPT, we give it feedback, good, not good, and so it wants to get a lot of good, right? What if it could hack our computers so that it always gets good? Then whatever it does isn't coupled with what we really want anymore. It just wants to make sure it controls that computer all the time, and it wants to make sure that human beings won't interfere with that. So it's a cartoon scenario I'm talking about, but there's serious arguments behind, and that's just one of the scenarios people have been thinking about. So yes, but it doesn't mean that there is no solution. It just means that if we go blindly without thinking of the consequences, there could be bad outcomes.
So I guess this
question over here.
Oh, hi. Thank you so much for your different perspectives. I'm wondering about neurodevelopmental and neurodegenerative diseases and what they can tell us about the interface between AI and neuroscience. So, for example, seizures have been modeled with attractor networks and things like this. And so how can, ChatGPT doesn't have epilepsy yet, but what types of
it hallucinates.
In terms of, obviously there's a lot to be gained from, mentioned earlier, about using AI to understand neurodevelopmental and neurodegeneration differently, but why does AI not have these issues in the same way?
I think that's a really interesting question. My first intuition is that neurodevelopmental disorders tend to be more tied to the biological basis of brains, and so they just won't happen. They're just things that aren't going to be captured in AI models. But the more interesting possibility is that that's not true, and that some kinds of neurodevelopmental disorders are, just kind of learning down a wrong route. Some kind of learning mechanism that goes awry. In which case, maybe they could be captured. I don't know anything about this, but I think that's super interesting. Maybe someone else.
AI already have a disease. It's called catastrophic interference. And I try at every cost to avoid that, because the complexity of that system, including ChatGPT, I assume, scales with the amount of information you put in. And as I try to say, human brains are different because the goal there is maintain its own dynamic. And adding new information does not perturb this very strong dynamic that goes on. So it's a different type of thinking, perhaps different advantages and probably many different disadvantages. But even a small brain doesn't have catastrophic interference unless you have something on like a brain injury or something like that.
Okay, so one final question over here.
So I want to know people's general thoughts on this. I feel like the biggest marvel of the brain isn't that we can do extraordinary things, but that we do them with extraordinary efficiency. So we have billions of neurons, trillions of connections, but we're able to use very little energy to carry out amazing feats. And then I look at AI models and I wonder, it's not really like that at all. It seems like they need lots and lots of processing time, lots and lots of energy, lots of iterations. And so I want to know, what are people's thoughts on this? Do you think this is the biggest challenge in AI? Do you think it just has to do with brains having very good priors due to evolution, or what are your general thoughts about this discrepancy between brains and AI?
I think the biggest question, we asked about the biggest question, the most important thing in AI right now perhaps is not consciousness and things like that, but how do you make it energy efficient? Because that is the constraint of evolution of AI or any computation.
So the energy efficiency of our brains is a result of the evolutionary constraint that we don't have gigawatts of power to, get that computation going. But in our society, because we have fossil fuels in particular, and we're destroying our planet, we can do it, and it has a lot of commercial value, and so we're doing it. There is not a lot of pressure right now. I mean, there will be soon, because we're going to exhaust all the available power very soon, to make those systems a lot more efficient. But I don't think we'll end up with the same solutions anyways as biology, because we don't need to be restricted to whatever 15 watts or something. We can actually use a lot more because we have those resources.
Question, isn't it the training that's most energy intensive? Yeah, not the running.
It's actually the loading and saving of the weights.
Yeah, and so if you can delegate some of that to evolution with some priors, then maybe it's not.
Yeah, right now, I mean, training is the most expensive, but then of course, if you run your trained neural net on 1 billion people, then it gets expensive too. So, it's...
Okay, well, I think in the interests of food, we should wrap it up.
Self-interest.
Exactly. Have biological needs. So, finally, a few words from Karim.
So, this was a blast. Thank you so much. Please join us in thanking all our panelists and